morning, everybody, and once again, welcome to Pankaj Sir's Echelon Tutorials. In this today's session, we are going to study IGCSE Physics, and in this particular session, we are going to start with a instrument very popularly known as a Vernier Calipers, but then many don't know the basic concept behind this Vernier Caliper. And if you want to measure the length or the width or the diameter of any object, this particular instrument is widely used, right? So let us study about this vernier caliper for today. To start with, what is a vernier caliper? Vernier caliper is an instrument. You can see the diagram over here. So uh, yeah, can you see this diagram over here? This is the diagram of a vernier caliper, right? Okay. Now, if you see this diagram, you will see various parts of this vernier caliper, and that is what I am going to discuss. But before that, let us pointwise go and see what is a vernier caliper. So basically, a vernier caliper, it is an instrument which measures the length, okay? And it is basically used for measuring length, which are, having even a size which is smaller than a millimeter, right? So that is what we call something as a least count. So that we'll be doing in our study further. So basically, this vernier caliper is something which can measure the length. Okay. Second, uh, a vernier caliper is an instrument which has a least count, and its least count can be around 0.1 millimeter or say 0.01 centimeter. Now, this least count is a very important concept, right, of a vernier caliper. The least count of a vernier caliper can be 0.1 millimeter or 0.01 centimeter, or there are least count, there are instruments which has a least count slightly more than this as well. Okay, so 0.05 maybe. So there are various least count that can be found in the vernier caliper. And the third point is some instruments have least count of 0.05 millimeter or 0.005 centimeter. As I told you, the least count can vary for a vernier caliper, right? Next point is it has two scales. One is a vernier scale, okay, and one is a main scale. So basically it has two scale, a main scale and a vernier scale, right? Now, if you see in this diagram, you can see this metallic strip, a long metallic strip, okay, where my cursor runs. This is nothing but a main scale, right? Now, on the top, the scale has been calibrated in something called imperial scale, okay? Now, this imperial scale has nothing to do with we people, okay? So, the scale at the bottom, can you see here? The scale at the bottom is marked in centimeters, right? So can you see it is 1 centimeter, 2 centimeter, 3 centimeter, up to around 15 centimeter, right? Okay. So 14 or 15 centimeter is marked, right? So this is the main scale, and we are going to take the reading of the object, okay, using this main scale. Then second type of a scale that you see is a vernier scale. Now, can you see this rectangular scale which can slide over the main scale, okay, with the help of this locking screw, right? So this particular scale, this rectangular scale which slides over the main scale is known as a vernier scale, right? So this is your main scale. I'll write MS for main scale. And this particular scale which slides over the main scale is something which is known as a vernier scale. So these are the two scales. Okay. Now, the other parts of this vernier calipers are these two are the jaws. Okay, these are known as the external jaws, and this is used for measuring the diameter of a circular object. Okay, or you can say if you have a cylinder, then you can find out the diameter of the cylinder, the external diameter of the cylinder using these two jaws. Or if you want to find the length of an object, the object has to be fixed between these two jaws. So these are the external jaws. Okay, you will find that there are internal jaws also over here, and this purpose of this internal jaws is many a times you need to find out the inner diameter. Okay, so there's something called inner diameter and outer diameter. So suppose you have a cylinder, okay, then this is your external diameter. which can be clamped in this way using your external jaws to find out the external diameter. But if you want to find out the inner diameter, this internal jaws, you'll have to fix it over here. So you can fix this internal jaws over here, something like this. Okay, and you can take the reading and can find the internal diameter using this internal jaws. This is a locking screw. Once you have locked this particular screw, the scale will be fixed. I mean, the vernier scale will not move. Otherwise, if you want to slide it, then you have to loosen this locking screw and you have to make it slide. As I told you, there is a on this main scale, you can you see this small rod like thing, protruding outside. Now this is known as the depth measuring blade. Okay, so when you broaden this jaws, okay, when you open this jaw, okay, this blade will also come out, and this particular depth measuring blade, as the name suggests, is used for measuring the depth. Okay, so suppose you have to measure the depth of a liquid or something like that, okay, inside this beaker. So you have to put this particular vernier caliper in such a way that this depth measuring blade, it is kept in this way, right? So this will measure the depth. Okay, so these are the various parts of the vernier calipers, and the main concept behind this vernier caliper is the least count. Okay, so reading is normally taken by recording main scale and the vernier scale readings. Now this we will be discussing when we come to that. Okay, so first let us try to find out what is a least count. Okay, least count of this vernier caliper. Now, okay, and final reading is given by main scale reading plus vernier scale reading. Okay, this all thing we can do when we are actually when I'll teach you actually how to take the reading using a vernier caliper. Okay, so vernier caliper, first of all, let me tell you, it was around in the year 1861. This particular instrument, vernier caliper, was invented by a scientist whose name was Pierre Vernier. Okay, and because of this name, vernier caliper has been given to this particular instrument. Now, basically, what happened is we know we should know what is a least count first of all. Okay, so let us talk about the least count. Now, if you take a normal scale, okay, the normal scale which you find in the compass box, okay, so normal scale is something which is a long scale like this, okay, and the calibration done on this scale is in inches, okay, on one side, and in centimeter on the other side. Okay, you can see this is in centimeters, something like this. Okay, right, so this is a normal scale. Okay, and you will find that there's in centimeter calibration done and there's a inch calibration done. Okay, now if you want to measure something like 1 inch, 2 inch, or something like that, you can use this scale very nicely because there is a inch calibration over here. Something if you want to measure in centimeter, okay, you can use this scale because centimeter marking is also there on this scale. Now, what is the meaning of least count? Now, what is the least measurement that you can take using this particular scale? Now, if I see this is inch, this is centimeter, and this centimeter is dividing 1 centimeter has been divided into 10 equal divisions. So if you magnify it and if you see the scale, it will be 0, starting with 0, then you have 1, 2, 3, 4, and then 5, and then 6, 7, 8, 9, and then 10. Okay, this 10 is nothing but 1 centimeter, right? So this distance of 1 centimeter has been divided into 10 equal parts, and this each small part is known as 1 millimeter. Okay, this is 1 millimeter. That is why we say that 10 millimeter makes 1 centimeter. Okay, so in a scale, in a normal scale, the least division is of 1 millimeter. The least division is of 1 millimeter. That is why we say that the least count of this normal scale is 1 millimeter or in centimeter you can say 0.1 centimeter. Now anything smaller than 1 millimeter you cannot measure using this scale. Why? Because you don't have that calibration on the scale. Okay, smaller than 1 millimeter, you don't have that calibration. So something is suppose 0.5 millimeter or 0.4 millimeter, you cannot measure because you don't have that calibration, you don't have that division to measure that 0.4 or 0.5 millimeter, isn't it? So anything smaller than 1 millimeter you cannot measure using this scale. That means the least count of this particular scale is 1 millimeter or 0.1 centimeter. Anything smaller than 1 millimeter and 0.1 centimeter you cannot measure. That's the meaning of it. But there's another meaning to it. Suppose you want to measure some object, then you can measure either if it is 1 millimeter, 2 millimeter, 3 millimeter, 5 millimeter, okay, 10 millimeters. You can measure these distances, okay, because you have the on the scale you have these things, okay. But suppose if you want to measure something like between 2 and 3 millimeter, okay, if you want to measure a length which is between 2 and 3 millimeter, then you will be in a fix, okay, because between 2 and 3 millimeter you don't have any divisions, because if this is 2 millimeter, this is 3 millimeter, in between this 2 and 3 millimeter you don't have any calibration, you don't have any markings, so you cannot measure any distance between 2 and 3 millimeter, right? So if the object is say 2.5 millimeter or say 2.25 millimeter, then these are the distances which you cannot measure, right, using this particular scale, the normal scale. And for that purpose, a scale was invented by Perry Vernier in 1861, and this particular instrument was called as a Vernier Caliper, and this Vernier Caliper can measure uh, length up to 2 dp, okay. So it can measure length up to 2 dp. 2 dp means 0.01. This is known as nothing but the least count of a vernier caliper. Okay. So the least measurement that a vernier caliper can make accurately is 0.01 centimeter. And that is nothing but the least count. Okay. So I hope you must have understood now the meaning of a least count. Okay. Now suppose a object is having a length of say 1.55 centimeter, then you can accurately measure this. Okay, 1.55 centimeter you can measure. Or suppose it has 2.35 centimeter. So these are the length which you can measure accurately using a vernier caliper, because in this measurements you have 2 dps. Okay, I mean the measurement is up to 2 dp. After the decimal point you have 2 digits, 35, you have 55. Okay, so this accuracy increases from the normal scale. Okay, the accuracy has increased in the case of vernier scale to 2 dp. Is that clear? Now let us try to understand the meaning of this least count. You have understood. Now how to find out the least count of a vernier caliper. Okay, now there is a formula, okay, a very general formula which says that least count of a vernier caliper, LC means least count, okay, least count of a vernier caliper is equal to MSD. MSD means main scale division, that is the smallest main scale division, multiplied by bracket 1 minus x upon y, where x and y are what? X is the main scale division coinciding with the vernier scale division, and y is the vernier scale division coinciding with the main scale division. Now this particular formula, I'm not going to just tell you to by heart this formula, but I'm going to make you understand how this formula has come into picture. Okay, so let us try to investigate how this formula has come to existence. Okay, and this is the formula for the least count of a vernier caliper, right? So let us try to discuss that. So I hope you must have understood the different parts of a vernier caliper by now, and you know what a vernier caliper is used for, and you must know that there's something called least count of a vernier caliper, which we are going deep into to understand now. Okay, so going ahead. Okay, Now, this is in 1631 that Perry Vernier invented Vernier Caliper, and this is a very important statement about Vernier Caliper. The division of the vernier scale, I told you in a vernier caliper you have two types of scale. You have something called main scale and you have something called vernier scale. Okay, so the division of the vernier scale being either slightly longer or shorter than the division on the main scale. So it has been found that the division on the vernier scale is slightly longer or slightly shorter than the division on the main scale. Now let me draw this and show you what I mean to say. Suppose this is your main scale, okay, starting with a 0. These are the divisions, okay, right? Now suppose these are the divisions, right, of the main scale. And you know that the vernier scale is always sliding over the main scale, okay. So suppose this is the 0 of the vernier scale and these are the divisions of the vernier scale, right? Okay. So what he wants to say is the division of the vernier scale can be either slightly longer or slightly shorter, okay, than the main scale division. So here you can see, if you concentrate here in this region, you can see that if this is, suppose the this is the 0 of the main scale and this is the first division of the main scale, okay. So I am magnifying this particular thing, and this is the 0 of the vernier, and this is suppose the first division of the vernier scale, okay. So this is your main scale and this is your vernier scale. Can you see this distance between the shortest distance, okay, or the distance between two consecutive divisions on the vernier scale is slightly lesser than this distance, that is the distance between the two consecutive divisions on the main scale, okay. So this is a situation where we can say that it is shorter, the vernier scale division is slightly shorter than the division on the main scale, but it can happen so that this particular distance is longer than the main scale distance, okay. But we are not going to go into that because that will be something which you should study in higher classes, right? Normally in the school section we are dealing with this only, where the vernier division is shorter than the main scale division, okay. So this is your one vernier scale division and this is your one main scale division, right? You will see, suppose this is your x and this is your y, okay, then you'll always find that y is less than x. The distance between the two consecutive divisions on the vernier scale is slightly less, okay, than the distance between the two consecutive divisions on the main scale, okay. This condition you will always see in a vernier scale. Generally, division on the vernier scale is smaller than the division on the main scale. As I told you, you don't worry about this slightly longer division because this is something which you will study in your higher classes. So generally, the division on the vernier scale is smaller than the division on the main scale. So you'll always find this kind of a case. Okay. So when you have this kind of a case, okay, let us say that on the main scale you start from a 0. Now concentrate on this. This is a main scale. So 0 you have and you have 1 centimeter. Okay. So in between 0 and 1 centimeter there are 10 divisions, right? So you can say that starting with 0, 1, 2, 3, 4, fifth division, 1, 2, 3, 4, and this is 1 centimeter, right? So this is 1 centimeter division and these are 10 small divisions. So these are each 1 millimeter. Okay. So the smallest division or one main scale division, that is this distance, okay, is how much? This is 1 millimeter. Or if you want to convert it in centimeter, it is 0.1 centimeter, right? So you can see that on the main scale, the smallest division of one main scale division is 1 millimeter or 0.1 centimeter. So all this distance, between these two consecutive divisions, okay, is nothing but 0.1 centimeter. Okay. Now can you see this vernier scale? Now this vernier scale is having 10 divisions, which is accumulated in the 9 divisions of the main scale. Now can you see this is 0 of the main scale? This is 1, 2, 3, 4, 5. This is the 5th division of the main scale. 6, 7, 8, and this is the 9th division of the main scale. Okay. So your vernier scale is made in such a way that in this 9 division, okay, of the main scale, the vernier scale will be having 10 divisions, okay, starting with the coinciding with the 0 of the main scale, you'll have the 0 of the vernier also. So 0 of the vernier is also over here, but now this 9 divisions on the main scale will be equally divided into 10 divisions, okay. So you will have slightly lesser distance between the divisions of the vernier scale, and you will have this way 10 divisions. How many? 10 divisions. So what we say is this vernier caliper is made in such a way that 9 divisions of main scale are equal to 10 divisions of vernier scale. Okay, 9 division of main scale are equal to 10 division of vernier scale, right? Now when we make this arrangement, what happens is this type of situation arises, that is, suppose this is one division of the main scale, okay, which is how much? It is 0.1 centimeter or 1 millimeter, okay, and into this you have this vernier scale ka one division, okay, this is the one division of vernier scale. Now vernier scale division is not calibrated in centimeter or anything, okay, it is just equal divisions, right? No one can say that it is millimeter, centimeter, nothing, okay, it is not calibrated, it is just equal divisions have been made. How many? 10 divisions. And this 10 divisions will be befitting into the 9 divisions of the main scale, which are indicating 9 millimeter. The 9 divisions of the main scale is equivalent to 9 millimeter. Okay. But this 10 divisions on the vernier scale, you cannot say it is equal to 10 millimeter. No, it is just 10 divisions, right? Equal divisions. So if I want to find out the value of this one vernier scale division, then it will be how much? Okay, so I know that 10 vernier scale division, 10 vernier scale division is equivalent to 9 millimeter, right? It is equivalent to 9 millimeter, right? So one vernier scale division will be equivalent to how much? So this will be 9 into 1, 9 divided by 10, which is equal to 0.9 millimeter. Okay. So one division of the vernier scale is equivalent to 0.9 millimeter. Okay. Now suppose you come down to this. So my x will be how much? It will be 1 millimeter. And my y will be how much? It will be 0.9 millimeter. Isn't it? And this x minus y, if I'm interested in this x minus y, what will be this x minus y? You know, it will be this particular distance, a very small distance. This will be my least distance that I can measure, which is known as the least count. So least count of the vernier caliper will be x minus y. Now x minus y will be how much? It will be 1 minus 0.9 millimeter. 1 millimeter minus 0.9 millimeter, which is equal to 0.1 millimeter. Did you get it? So this 0.1 millimeter is something which is giving me this value x minus y. Okay, this has to be your least count, but least count is this main scale division, that is MSD, is 0.1 centimeter. That multiplied by this 0.1 will make you the will give you the least count. So least count will be equal to 0.1 into 0.1, that is 0.1 centimeter. This has to be your least count, 0.01 centimeter. Okay, now this I have tried to explain you in a very not in a practical way, but in a logical way. Okay, so maybe you must have not understood yet. Okay, how come the least count of a vernier caliper is 0.01 centimeter. But then if you try to go still deep into it, into the formula, you will get it. Okay, so now let us try to go deep into the formula to find out the least count. Okay, so let us try to understand this least count from the formula. As I told you, the formula for least count is equal to 1 main scale division multiplied by 1 minus x upon a y. Okay. Now, what is the 1 main scale division in a vernier caliper? 1 main scale division is 0.1 centimeter. It is 1 millimeter, or you can say 0.1 centimeter. So let us go in centimeter. So it will be 0.1 centimeter. This is 1 MSD times 1 minus x upon y. Now what is x? X is the, now this is something which is known as the principle of vernier caliper. Okay, principle of a vernier caliper. That is, a certain number of ms, certain division of main scale will be fitted into certain division of vernier scale. Okay, and these are always having a difference of 1. So you can say that n divisions of vernier scale in general can be coinciding with n minus 1 division of main scale. Okay, so this n minus 1 on the main scale is nothing but the x value, and this n division on the vernier scale is your y value. In this case, your x is 9 and your y is 10. So if you put in this formula, x will be 9 and y will be 10. Now if you work out, this will be 0.1 centimeter times 1 minus 9 upon 10 is 0.1 minus 0.9. This is equal to 0.1 multiplied by 1 minus 0.9 is again 0.1. So this happens to be 0.1 into 0.1, which is nothing but 0.01 centimeter. So this is your least count. This is the least count of the vernier caliper. Now this particular uh, thing, that is 9 division of the main scale, is made to coincide with 10 division of the vernier scale. This is known as the principle of the vernier caliper, and this helps you in understanding that the least count can be manipulated. Now if you want a least count still smaller than 0.01 centimeter or slightly more than 0.01 centimeter, then you can always change this thing. Okay, so instead of 9 and 10 you can take some other values. Okay, but the difference should be of 1 only. Okay, so that is the principle of vernier caliper. I hope you must have understood the principle of vernier caliper. And now, what is the least count? Let us try to understand that. Least count of an instrument is the least measurement that can be measured by that instrument accurately. So now with a vernier caliper, you can measure any distance which is, up to 0.01 centimeter. That is the least distance that you can measure. Anything smaller than 0.01 centimeter, you cannot measure using a vernier caliper. But anything up to 0.01 centimeter, you can measure. For a normal scale, the least count is just 1 millimeter or 0.1 centimeter. For a protractor, you must have seen a protractor that we use for measuring angle. In a protractor, the minimum measurement that can be accurately taken is 1 degree. Okay, so the least count of a protractor is 1 degree. And for a wall clock, if you happen to see a wall clock in your home or somewhere, okay, the least measurement that you can accurately measure is of 1 second, because the second hand, it moves, and when it moves, you can see that the least calibration is of 1 second. So least count of a wall clock is 1 second. Okay, for a vernier caliper, the least count can be 0.01 centimeter. There are certain vernier calipers where the least count is 0.05 centimeter. Okay, so depending upon the x and y values that you have taken in a vernier caliper, the least count of a vernier caliper can be still reduced. Okay, now what is the significance of least count? Suppose you want to measure uh, certain distance. Okay, now let us see this. You are given a length, okay, of a particular object as 10.7 or say 10.81 and 10.825. Okay, these are the length given in centimeters, right? Now what you can say from this is the length of 10.7 centimeter is having less accuracy because it is giving you the reading only up to 1 dp, right? 10.81 is slightly more in accuracy compared to 10.7. Why? Because you can see there are two decimal places after the decimal point. So this is a reading of up to 2 dp. This is 1 dp, right? And 10.825 is still more accurate compared to even 10.81 because in this 10.825 you find that there are three decimal places. Okay, so whenever the decimal places increases, that indicates that the accuracy has been increased. Okay, so it is more accurate. So this 10.825 centimeter is a more accurate reading of the length of an object compared to 10.81 and 10.7. Okay, so the accuracy of measurement increases. Now why, when this happens, this happens when the least count of the instrument decreases. So you can understand that the least count is inversely proportional to the accuracy. As the least count decreases, the accuracy increases. Okay. So 10.7 is the measurement taken by maybe your normal scale. 10.81 centimeter is the reading that you must have got of the same object, but this time it is not using a normal scale, using a vernier scale or vernier caliper. Okay, and 10.825 is a more accurate reading which you must have got using a micrometer screw gauge. Okay, micrometer screw gauge is an instrument which is having a least count in terms of 0.001 centimeter. Okay, so it goes up to 3 dp. So as you increase the least count of a instrument, okay, as you decrease the least count of an instrument, the accuracy that you get by of the measurement that you take using that instrument increases. Okay, so least count and accuracy are inversely related to each other. So vernier caliper is an instrument which will give you a least count of up to 2 dp, but micrometer screw gauge will give you up to 3 dp, right? Micrometer screw gauge also will be studying, but that will be in the later stage. Okay, so I hope you must have understood the basic principle of this vernier caliper. Here I am trying to show you how the 9 divisions of the main scale. Can you see this is a main scale? And this main scale, now this is not rightly written by me. This should be, okay. Okay. This should be 1 centimeter, right? This is 1 centimeter, right? So you can see here on the main scale, this is 0, 1, 2, 3, 4, 5th division, 6, 7, 8, and 9 division. So this is still here, it is 9 millimeter. Can you see? So 9 millimeter is coinciding with the vernier scale. How many divisions? 10 divisions. Can you see? 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. So on the vernier scale, 10 divisions are coinciding with the 9 divisions on the main scale. So this is the principle of this particular vernier caliper. In this case, your least count is going to be 0.01 centimeter, isn't it? Now, there can be another case. Now this is the same thing. Okay, I don't know why I've repeated, but this is the same thing. Okay, but you can have 20 vernier scale division coinciding with say 10 main scale division. Okay, this situation can also arise, but in this case the least count will be different. Let us try to find out the least count in this case. In this case, the least count will be, the formula is least count is equal to smallest division on the main scale, 1 msd, bracket 1 minus x upon y. So smallest division on the main scale is always 0.1 centimeter. Bracket 1 minus, now x upon y. Now x will be your 10 and y will be 20. So I'll have to take 10 upon a 20. Now this works out to 0.1 bracket 1 minus this 1 by 2 is 0.5 and 1 minus 0.5 is 0.5. So this will be 0.1 times 0.5, which works out to 0.05. Can you see in this case we are getting a least count of 0.05. Now 0.05, okay, is the case of least count when we take this particular principle, okay, that is 20 division of the Vernier scale. We are going to coincide with 10 divisions on the main scale. Okay, so least count will be 0.0. That way, the least count of a Vernier caliper can be manipulated and it can be made to, any desired level that we want. Okay, so this is an example of 0.05 least count, 0.05 centimeter, and this is an example of 0.01 centimeter least count. Okay, getting it? Now 0.01 is less than 0.05. So the accuracy will be more by using this particular instrument, okay, which is having a least count of 0.01 rather than using this 0.05. Okay, so that's all for today. In the next video, I will be demonstrating with you in front of you, and I'll teach you how to take the measurement. But by that time, you should be very thorough with this least count concept and all that. Okay. So in the next video, I'll be just making you understand how to measure the various distances, whether length, whether the diameter, using a vernier caliper. Okay. So that's all for today. See you. Goodbye. Take care, all of you.